Bismillahirrahmanirrahim. Assalamu alaikum. My name is Fiz Ahmed. I am student of BTS first year. So today my topic is the islets of Langerhans, and these islets of Langerhans are present within the pancreas, and the pancreas lies behind the stomach. So I will take the small section of the wall of the pancreas to show the organization of the different cell within it. So basically, it contains the important cells, large cells known as the acinar cells, and the four more other cells which are really important. The first one is the PP cell, secrete the pancreatic polypeptides. Delta cell, important in the secretion of the somatostatin. Alpha cells, which are important in the secretion of the glucagon, and the beta cell play important role in the secretion of the insulin. So now I will explain about the insulin and the glucagon and its regulation and the action. I will explain about the regulation of the insulin. So first I will explain its stimulating factor. The first factor is the hyperglycemia. Hyperglycemia is a condition of the high blood sugar level, and this condition will stimulate the pancreas to secrete the insulin, which will convert the blood glucose into the glycogen within a liver, and as a result of it, the low blood sugar level will occur. The second effect is the glucagon. Glucagon is the hormone which is opposite to the insulin, and it will cause the high blood sugar level, and in other words it will cause the hyperglycemia, and hyperglycemia is the stimulating factor of the insulin, as I told you before. The increased blood free fatty acid concentration also stimulate the insulin secretion. When there is increased free fatty acid concentration, uh, then there will be accumulation of the fatty acid within the adipose tissue, and this will stimulate the insulin to convert the fatty acids into the more good type of the fats known as the triacylglycerol. And the fourth effect is the parasympathetic stimulation. Basically, the parasympathetic condition is a condition in which there's a low respiratory rate and the increased digestion rate. So when the digestion rate of the food will be increased, then the absorption of the glucose from the food will also increase, and as a result of this, the glucose level within a blood increases and create the condition known as the hyperglycemia, and hyperglycemia is the stimulating factor of the insulin. The fifth factor which stimulated secretion is the beta adrenergic stimulation. Basically, this stimulation or this effect is caused by the beta adrenergic cells, and these cells are opposite to the beta cells which produce insulin. So, these cells will decrease the insulin concentration, and as a result of this, the hyperglycemia will occur, and hyperglycemia is a condition in which there is high blood glucose level, and this effect will stimulate the insulin level to increase to decrease the blood glucose level. The final stimulating factor is most important, the insulin resistance, or which cause the obesity. Basically, this is caused by the increase in the concentration of the pro-inflammatory adipokines, and decrease in the concentration of the adiponectin. This substance involved in the regulation of the glucose within our body, or the fatty acid breakdown. And when there is decreased concentration of the adiponectin, then these two roles will not be played by the adiponectin. So these two effects will cause the insulin resistance, and as a result of insulin resistance, lipolysis in the adipose tissue will be increased, or we can say that breakdown of the triacylglycerides stored in the fatty acids will also increase, and due to the breakdown of the triglycerides, the free fatty acid concentration in the portal circulation will increase, and this effect will cause further two effects. The first one, that the fatty acid ingress in the liver will also increase, means that fatty acid accumulation within the liver increase, and it will also damage the beta cell which are involved in the secretion of the insulin. So accumulation of the fatty acids within liver will cause the condition known as the steatohepatitis, and it is the inflammation of the liver with fat accumulation. So steatohepatitis will cause the liver to increase the rate of the gluconeogenesis, and gluconeogenesis is the genesis of the glucose, and this will cause the hyperglycemia. And I told you just before that hyperglycemia is the stimulating factor of the insulin production. Now I will explain you about the inhibiting factor. The first is the hypoglycemia, and this is a condition in which there is low blood sugar, and it is opposite to the hyperglycemia. The starvation, exercise. The fourth one is the stress. Stress is basically the sympathetic condition in which the respiratory rate will be high and the digestion rate will be low. So due to the decreased digestion rate, the blood sugar level will also low, and it will cause the inhibition of the insulin. And the adrenergic activity, which is opposite to the beta adrenergic activity. So now I will explain about the action of the insulin. Insulin act on the metabolism of three different things. The first one is the fat metabolism. Within the liver, the insulin will act on the fatty acid to convert it into the triglycerides in the adipose tissue, and within the adipose tissue, this insulin will act on the triglyceride to restrict its conversion to the fatty acid. In the carbohydrate metabolism, when there will be high blood sugar level, means when there will be the condition of hyperglycemia, it will stimulate the pancreas to secrete the insulin, which stimulate the formation of the glycogen. And within the liver, this insulin will convert the glucose to the glycogen, and this effect will cause the hypoglycemia, and as a result of the action of the insulin, the rate of the gluconeogenesis within the liver will also decrease. And on the protein metabolism, it causes the active transport of amino acids into the cell, and promote the translation of the messenger RNA in ribosome to form the protein. So here I have explained you about the regulation and the action of the insulin, and glucagon is exactly opposite to the insulin. So here we are done with our topic. Thank you so much.